In today's lesson, we're going to be learning about negative binary numbers and binary subtraction. For today's starter activity, I want you to try and complete the sum 12 minus 5, but only using addition. How can you do it? Well, actually, if we negate the number to be subtracted and add it to 12, it's actually a minus. Now, when we want to represent a negative number in denary or decimal, we just put a negative in front of it. So 5 would become negative 5, or a small dash in front of it. Now, the one way which we actually could do this would be to use the first bit of our byte to represent 0 as a plus and 1 as a negative. This method is known as sine and magnitude. It's not the only way of doing this, and it has some big drawbacks. You can see the value on the screen in binary, which is 5, the first one, and the second one represented by minus 5. You can probably see that actually this is not going to be successful when we need some larger binary numbers and when we even try and add binary numbers together. So here is another issue of using sine and magnitude. When we try and add the two binary numbers together, the result, so minus 5 and then add 10, the result gives us minus 10. Well, we know the answer should actually be 0, because minus 5 add 5 is 0. We therefore need a more efficient way of doing this, and we use a method called 2's complement. Now, with 2's complement, the first thing to think about is a byte actually no longer holds the values 1 to 255. Instead, a byte would hold the values minus 128 to 127. It's actually the same amount of numbers that we're using, but we're using the byte slightly differently. So with 2's complement, we'd keep 0 as you'd expect it to be, 1 and 2, and we'd count upwards as we would normally. But in this case, only up to 127. Now, like we did in sine and magnitude, the last bit is represented by our 0. It's our sign. So like we did in the sine and magnitude, the first bit is changed to a 1. That's our minus. It shows it's a minus. But in order for our binary addition to work, we have to do something slightly different, and this is where 2's complement comes into place. The 7-bit binary numbers are actually inverted and then add 1. So any number that is a 0 has to change to a 1, and any 1 has to change to a 0, followed by the last step of adding 1 to that number. So here's our example. If we were to write out the value for minus 2, we would write out 2 first in binary. So that is 6 zeros, 1 0. We flip the bits so they all become 1s, apart from the second to last one. Then we add 1 to it. So as if we're counting up in binary, we add 1. So minus 2 would be 7 1s and then a 0. 3 works in exactly the same way. We write it out in normal binary. We turn it to a minus, we flip the bits, so all the 0s become 1s and the 1s become 0s. Then we add 1 to it. So minus 3 would be 6 1s, 0, 1. Minus 1 is actually all 1s. Now, if you would imagine that if we were writing 1, this would be a little bit different because we'd have 1 at the end. We'd have 7 zeros and a 1. If we flip the bits, we'd have all ones and a 0. We add 1 to it, and that makes our minus 1. So remember, there's a purpose to why we wouldn't use sine and magnitude and why we actually use 2's complement. That's because our addition actually works. So we have minus 5 and 5. You can see minus 5, we wrote out 5, we've flipped the bits and we've added 1. We can then do our addition and you'll see the answer is 0. You can forget the one which is carried for now. So, for converting positive to negative numbers using 2 complements, we flip the bits and add 1. And in the same way, we can reverse this to convert negative numbers back to positives. So you subtract 1 first, then flip the bits around. There are 4 different negative numbers here. I want you to try and complete these, writing the numbers out using 2's complement. Pause the video now and complete that. Here are our answers. Check your answers and make sure you've got them correct. Now what's wrong here? 128 and minus 128 actually give the same values. Well, hopefully you've spotted that the largest number we can make is 127, because the range of 2's complement numbers goes from minus 128 to 127. Now in our exam you're going to be expected to do binary subtraction as well. Now, actually it's really simple to do all of this, because actually to do subtraction all you need to do is add a negative number, as we looked at the start of the lesson. If you actually asked to calculate 9 minus 3, all we have to do is rewrite the subtraction. 9 plus minus 3. So what we can do is do everything that we've been used to. So we write out 9, we write out 3, we flip the bits and add 1. So then we have 9 add minus 3, which gives us 6. And you can just ignore the overflow bit for now. Now here's another example. Create a binary subtraction, which is to calculate 1011 minus 0101. Remember, the first thing we use is 2's complement. And a question will usually ask you and tell you, using 2's complement, create the following binary addition. So we make sure it's a negative binary number. When we're writing it out, we need to make sure we put our minus in front of the values. That helps us to remember that that is a negative number. So the first thing we do is flip the bits and we add 1 to the results. So minus 0, 1, 0 becomes 1, 0, 1, 1. We can then perform the addition. So 11 minus 5, we know it's 6. We check our addition and check our addition using binary and in our heads using the denary to make sure it's correct. So this is really an addition, remember. Remember, the numbers are being added because it's 2's complement. And we can add, when we add a negative number, it's like minusing a negative number. Here's another example, this time using 8-bit binary. So we've got two values, 155, we want to minus 37 from it. So first up, let's rewrite that calculation with a minus. Flip the bits, add 1 to the result, and then perform the calculation. Remember, in this case, we ignore the overflow bit. Remember to check your working to make sure it is correct. Now for this example, I want you to try this yourself. See if you can figure it out without looking at my example first. So the first thing we do is rewrite our calculation. We convert the second number to a minus. We do that using 2 complements by flipping the bits and adding 1 to the result. We can then perform our binary addition. Now just think about this. If the second number is larger than the first number, you know that after the subtraction the number will be negative. So we're going to have to perform 2's complement on your answer. Because the second number is, in this case, is larger than the first, the answer needs a 2's complement conversion. So again, we have to do exactly the same. We have to turn it back from the binary. So this time, instead of adding 1, we need to subtract 1. Then we need to flip the answer. And I want you to complete this task. Number 1, explain the issues with sine and magnitude. Number 2, using the example, show how 2's complement works and explain an advantage of this method. Number 3, represent the following numbers in 2's complement. Remember to make sure you show you're working in full. And then number 4, subtract the following binary numbers. And if the answer is negative, remember you must use 2's complement to work out the value of the negative binary number. You should always show your working.